Hello guys, and welcome back to another episode of chemistry. And of course, today we are going to be looking at stoichiometry. All right, stoichiometry is a very important concept in chemistry. Very important concept in chemistry that helps us to calculate the amount of what of reactant and product involved in a reaction. It is very useful. Okay, and of course it's a very wonderful concept because it is expected that what you as a chemistry student must have a knowledge of stoichiometry. Okay, you must have basic knowledge of stoichiometry and you must understand how to solve stoichiometric problems. Okay, so in stoichiometry, we say stoichiometry, first of all, is the quantitative study of reactants and products involved in a reaction. Okay, we say the quantitative study of reactants and products involved in a reaction. Okay, it helps us to calculate the amount of what it's just to use a balanced chemical equation. So during the course of this class, we also learn how to balance chemical equations. All right, we're going to use three questions. But this is the first question. I'm going to use to further understand this class. All right, so in those questions we'll have a different chemical equations, so it will give us a little knowledge about how to balance chemical equation. For so many of you have been commenting that you need to need a video on how to balance chemical equation, and those of you have been saying you need stoichiometry video. All right, this is for you. Also, because the next topic we are going to chemical energetics. Okay, we are going to talk about different heat of reactions. Okay, and the questions that usually come out on that different heat of reaction, we also need a basic knowledge of stoichiometry. That is why we are doing this today. So stick with us and keep learning. Do not forget, this tutorial is brought to you by the one and only O3 School JAMB. Okay, it is all you need to succeed in your exam. If you want to succeed and not succeed, if you want to succeed and not succeeds, okay, you need to get the application on your phone. Okay, get the application on your phone. Go to Play Store right now and download the application, right, and start using it to practice. It is a CBT practice app, and your exam is a JAMB CBT exam. It has all the past questions you can ever ask for, question search feature, UTME challenge that will conduct every Saturday. It's a mock challenge. Okay, so you do not even need to partake in JAMB mock, because every Saturday you have a mock on the you have a mock exam on the application. Okay, so it has all the past questions you can ever ask for all the subjects. So you don't need to go and get a regular past question for 1,500 for one. Okay, 1,500 times 4 is 6,000 naira. Okay, you want to go and get 4 past questions. This one has all the past questions and the whole app plus the mock challenge plus the classroom feature where it has lecture notes and structured according to the JAMB syllabus. Everything in that application is just 3,000 naira. So do not be stingy to yourself. Some of you say that don't have any knowledge of how to create app. Okay, you'll be saying it's too cost. That's a problem. All right, so please get the application, download it, activate it. If you want to activate, the application is also available for PC, for your computer. So in case you want to get the download link for your PC, just send a message to this number on WhatsApp, 09121515246. Okay, so if you want to download for your computer or you want to activate the app, send a message to this number on WhatsApp, or you can call the number. All right, so please, first importantly, go and download the application. So we say stoichiometry is the quantitative study of reactant and product involved in a reaction. So when it comes to stoichiometric problems, right? When it comes to stoichiometric problems, we encounter 3 main type of problems. Okay, so the first one, we'll be told to convert from mole of substance A to mole of substance B. Okay, so this is one of the first basic problems we see in stoichiometry. We are asked to convert from the mole of a substance A to mole of a substance B. This is the simplest stoichiometric problem we can ever face. All right. Now, another one usually given is converting from mole of a substance A to gram of substance B. Yeah. So another type of problem we'll be giving is what? To convert from mole of a substance A to gram of a substance B, or from gram of what? Substance what? A to what? To what? To mole of what? Substance what? B. Okay? So this is another type of problem we are giving you what is stoichiometry. All right? It's also very easy. So please don't bring your mind down, all right? Because we're going to what? Try to what? Deal with it accurately. Then the third type of problem we usually encounter when it comes to stoichiometric problem is converting from what? From gram of a substance A to gram of a substance B. This is another stoichiometric problem we encounter. All right, from gram of a substance A to gram of a substance what? B. Okay, this one usually involves 3 steps. 3 steps. This one involves what? 2 steps. This one involves just only 1 step. Very, very easy. Okay, so understand this first, that these are the only problems they can give you in stoichiometry. You get me now? So if you know this, you will know peace. All right, understand these are the only 3 problems. Converting from mole of a substance A to mole of a substance B. Converting from mole of a substance A to gram of a substance B, or from gram of a substance A to mole of a substance B. That is gram to mole, mole to gram. You get? Then the third problem is converting from gram to what? To gram. Okay, this one is usually what? The longest. Okay, gram to gram. This one is shorter. This one is the shortest. No, the first step is what is the shortest. Okay, so but for stoichiometry, you must have the knowledge of balancing chemical equations. Okay, if you do not have the knowledge, if you do not know how to balance chemical reactions, you will most likely fail a stoichiometric problem, because this is the core. All right, and of course, stoichiometry helps us to use balanced chemical equations. I think I mentioned that, to use balanced chemical equations to what? To calculate the amount of reactant and product present in a reaction. So you must have the knowledge of how to balance chemical equations to be able to answer stoichiometric problems. All right, so let's head way to it. So mole of A to mole of B. So let's see an example under what this. All right, so as we progress before we get to the third example, we must have encounter each of these issues. All right, now let's see the first question we have on the board. Okay, so we're told that sulfur dioxide, you know what sulfur dioxide is, right? Sulfur 4 oxide, SO2, sulfur dioxide. All right, so some of you say, why there's no P here? Okay, so this spelling is also very, very correct. So sulfur dioxide, which is SO2 now, SO2 reacts with oxygen gas. Oxygen is It's a diatomic element, okay? To form sulfur trioxide. You know sulfur trioxide, right? Not SO4, but SO3. SO3, sulfur trioxide. All right, so now, we first need to first of all get our reactions out of the way first. Okay, we are told that sulfur dioxide, that's SO2. Okay, let me bring this into 2 so that I can have space. Okay, sulfur dioxide, SO2, reacts with with oxygen gas, O2, to give us now? SO3. All right, so this is the reaction. Okay, sulfur dioxide reacting with oxygen gas to form sulfur trioxide. That is the reaction. Okay, now it's expected of us first to balance this equation before we start for reading any other further part of the question. All right, so now, is this reaction balanced? How do we tell that a chemical reaction is balanced, so the chemical equation is balanced or not? Okay, so we must have the same number of the same atoms of each element in the reactant and the product. So in the product side, on the reactant side, this side here, this left-hand side is the reactant side, while this right-hand side was the product side. So the number of atoms of each element will be the same in the reactant and the product before we say a chemical equation is balanced. All right, so we must first of all balance this equation. Now, how do we do that? There's sulfur here. S is sulfur, right? Okay, how many atoms of sulfur do we have here? Just 1. Only 1 atom of sulfur. As we start now, this S, okay, let me just say S, 1 atom. Okay, now, but let's go to the right hand side now, to the product side. How many atoms of sulfur do we have here? It's still 1. So S is still 1 here. All right, so that means the next thing we need to look at what is the oxygen. S seems to be balanced for now. For now, it seems to be balanced. Okay, now let us now look at the oxygen. How many atoms of oxygen are in the product side here? This is what? 3 atoms. Okay, SO3. 3 atoms of what? Of oxygen. All right. Now, how many atoms of oxygen are in the reactant side? This is 2 here, first of all. Okay, in this SO2, this is another 2 here in this what? SO2. Okay, so that means oxygen here is what? Is 4. Okay, 4 in the reactant side and what? 3 on the what? On the product side. So that means that what? There's a dichotomy in the number of atoms of what? Oxygen in the what? Product side and the reactant side. And it cannot be what? In fact, there cannot be dichotomy. They have to be what? They have to be the same. So you have to look for a way to what? To make the number of atoms of what? Of oxygen on the right hand side and on the left hand side to be what? To be the same. All right. So how do you do that? So we now what? Look for what? For factors to add. All right, so let's just start from the lowest number. Let's say we cannot add 1 because 1 will not have any effect on what on them. Okay, but if we can start from 2. So that means if we add 2 atoms here, okay, because what they are, why we're starting with this product side, because product side has lesser number of what? Oxygen. You get it has a lesser number of what? Of oxygen. Okay, so if we add 2 here, all right, how many atoms of sulfur do we now have? This 2 molecules of sulfur trioxide. Okay, so that means there are 2 atoms of sulfur and 2 times 3 atoms of oxygen. Understand that? 2 atoms of sulfur, 2 times 3 atoms of what? Of oxygen. All right, so that's what we do. Now, how many atoms of sulfur do you now have here now? After adding 2, we have 2 atoms of sulfur. How many atoms of oxygen do you now have here? We now have 6 atoms of what? Of oxygen. Okay, so now let's go to the right. All right, so we already have 2 atoms here and 2 atoms here. Where should we add 2 so that what? This reaction will be balanced? If we come and add 2 here, okay, if we add 2 here, sulfur will be what? Sulfur will be 2. All right, sulfur will be 2, and then O2 will be what? Will be 4. Okay, then plus this O2, right? So that means what? If we add 2 here, okay, also S will now be what? 2. 2 times what? O2 will be what? Will be 4 here, then plus this 2 here. You know, this one is the what? Number of oxygen on the reactant side. 2 times S is 2S. That means sulfur has 2 atoms. Okay, then but oxygen will have what? 2 times what? O2. 2 times 2 is what? Is 4. Then plus this 2 again that is here, plus this 2 here, that will be what? 6. That will be 6. Okay, so you see that now the number of the atoms of what? Of sulfur on the what? Reactant side, and the atom of sulfur what? On the what? Number of atoms of what? Sulfur on the product side is what? Is the same too. The number of atoms of oxygen on the what? On the product side is 6. The number of atoms on the what? On the reactant side is also 6. So now we now have a balanced chemical equation. Right? In the next example, I'm not going to take this long to explain. All right, I'm just giving you heads up for those of you who do not really or truly understand how to balance chemical equation to be able to fully understand. Now let's go back to our question. So say sulfur dioxide reacts with oxygen to give you sulfur trioxide. All right, that means in stoichiometry we can use what? Ratio. All right, that means what? The ratio of what? Sulfur dioxide that reacts with the ratio of that reacts with oxygen. Okay, is what? This is what? 2 molecules of sulfur trioxide. All right, we are using mole ratio now. 2 molecules of sulfur trioxide and what? 1 molecule of what? Of oxygen. That means that what? That to form what? SO3, 2 SO3 here, right? 2 molecules of sulfur trioxide must react with 1 molecule of oxygen. Okay, for us to be able to get 2 SO3, 2 molecules of sulfur trioxide must react with what? 1 molecule of oxygen to give what? SO3, 2 SO3. All right, so now that is not the main part of the question. Now they say if 3.4 moles of sulfur dioxide, reacts with excess oxygen gas, okay, how many moles of sulfur trioxide will be formed? Okay, now that means that you have to look for what? You have to first of all understand what they are comparing. Okay, now look at it. In the question here, we are comparing sulfur dioxide and what? That first part of the question with what? With sulfur trioxide, right? We're given the number of moles of sulfur dioxide, and then we are told to look for the number of moles of sulfur trioxide that will form. Okay, so now the concept of excess reagent and limiting reagent. Let me just quickly talk about it. Okay, excess reagent is the word. It's the reagent that is what? That is not completely used up. Okay, it is excess from the word excess. That means it may anywhere, right? So the reaction ended, but one of the reactant also was still left over. Okay, some of the reactant were not what completely used during the reaction. Okay, while limiting reagents, that means it's a reagent that is a reactant that's all completely used up during the reaction. Okay, and most times once the limiting reagent has finished, the reaction will stop. Okay, so it will stop, and then we'll not have excess. We'll not have excess reagents. Okay, so the limiting reagent is the reagent that is used up during the reaction, while the excess is one that is left over afterward the reaction. Okay, now let's say if 3.4 moles of sulfur dioxide react with excess oxygen gas, how many moles of sulfur dioxide will form? So when you come to this your reaction now, you should know first of all that we are comparing sulfur dioxide and sulfur trioxide. Okay, so from our equation, we're told that how many moles of here? That 2 moles of SO2. Okay, gives us 2 moles of SO3. I have to first of all understand that. All right. So you understand that concept, right? So I want to take this up so that we can have we can have a bigger space. Okay. So if I say I'm saying like 2 moles, right? React with what? How many moles of SO3? 2 moles. All right. Now we're given that if 3.4 moles of sulfur dioxide react with excess oxygen gas, how many moles of SO3 will be formed? Okay, that means we're given that 3.4 moles now. If 3.4 moles react with excess oxygen gas, okay, how many moles of SO3 will be formed? Okay, so here is what we don't know. Simple as ABC. You get now. So 2 moles of SO2 reacts with 2 moles of SO3. Okay, from the reaction, from our balanced chemical reaction, it is 2 moles that gives rise to 2 moles of SO3. Okay, so that means 2 moles gives us 2 moles. Okay, of SO3. That's 2 moles of SO2 reacts with 2 moles of SO3. Now 3.4 moles will give us how many? Okay, it give us X. So what we simply do is is cross multiply. I'll do this. That means you use this to you go like this, then you'd go like this. All right, that means this times this times this. Now let's multiply. 2 times X is equals to 3.4 times 2. You get. All right, so now 2x is equals to what now? That will be 6.8. All right, so 6.8. Okay, what do we do next? Look for the value of S. Divide both sides by 2. Divide both sides by 2. X will be 3.4 moles of now? Of SO3. That's what we're going to have. All right, now we're having 3.5 moles because the ratio of of SO2, right, to SO3 is 2 ratio 2. That is 2 moles of SO2 gave us 2 moles of SO3. And if you reduce this ratio, we're going to have 1 ratio 1. That means even if you put 100 moles of of SO2, right, it will give us now? 100 moles of of SO3. All right, you get. So because of the ratio in which they are combining, okay, if you put 5,000 moles of SO2, it will still give us 5,000 moles of SO3 because of this ratio, 1 ratio 1. They are combining in the simplest form of this ratio, 2 ratio 2 is 1 ratio 1. So they combine 1 to 1. If you bring 1, it will give you 1. If you bring 2, it will give you 2. If you bring 3, it will give you 3. That is from the balanced chemical equation. No, it's not something you should cram. That is not what you should put on your head. All right, what you should understand is that you must have a balanced chemical equation first. All right, so that is what to give us. So we are very correct because of the ratio. The ratio is 2 to 2. I mean, if you bring 3.4 moles of SO2, it will give us 3.4 moles of SO3. Simple as ABC. Now, let us look at the second part of the question, which I'm sure you can pause now and do it yourself. Okay? All right, so now let's go. They say, how many moles of oxygen gas react? Now, we're comparing oxygen gas and and sulfur dioxide. They say, how many moles of oxygen gas will react completely with 4.7 moles of sulfur dioxide? Okay, so now you have to bring the reaction down here. I'm having 2SO2, okay, then plus plus O2. All right, now the ratio in which they combine is is 2 to 1. All right, so this is 2 moles of SO2 to what? 1 mole of O2. That's what we have. 2 moles of SO2 to what? 1 mole of O2. That's what we have. All right, now we are told that how many moles of O2 will react completely with 4.7 moles of sulfur dioxide. Okay, that means we have what? 4.7 moles here. 4.7 moles of what? Of SO2 will give us what? X what? O2. X moles of O2. Simple as ABC. So what do we do? The same thing, we cross multiply. All right, that means I'm going to have 2 times what? X is equal to what now? 4.7 times what? 1. All right, so now 2 times X is what? Is 2X, which is equal to what? 4.7. Okay, so to find X now, X will be equal to what? 4.7 divided by 2, which will give us what? 2.35 moles of what now? Of O2. So it's simple. So this first part of what? Of stoichiometry, are trying to convert what from mole of a substance to mole of another substance is very, very easy. It's pretty one-step what process. Okay, so please go over the video again. Right, in case you do not understand for any reason, go over the video again. All right, because right now we're going to the second example that will now make us to convert from mole to gram or from gram to mole. All right, so now let's get there. So welcome back. Sorry for the long display. All right, so now we're given a question here. I told that propane C3H8 react with oxygen gas to form CO2 and H2O. All right, now that means we need to first of all bring out our balanced chemical equation. Okay, it's very, very important. Now let's go. So we're having what? C3H8, that's propane. All right, reacting with what? Oxygen gas, that's O2, now to give us CO2 plus what? Plus H2O. This is the balanced, this is not the balanced chemical equation, all right? So we need to make this equation with balance. Now, let's start with carbon. How many atoms of carbon do we have here? We have 3 atoms of carbon here. Yeah? Now, how many atoms of carbon do we have here? We have 1. You get now? So now, let's look for a way to make the number of atoms of carbon on both sides to be the same. All right. So if you put 3 here, 3 atoms of carbon here, 3 this to balance what these 3 atoms of carbon on this left hand side. All right. So now carbon is balanced. Carbon is balanced here. Now let's have to talk with hydrogen. How many atoms of hydrogen do we have here? We have 8 atoms of hydrogen here. H8. Here we have how many atoms of water of hydrogen here? The number of atoms of hydrogen here is just 2. Okay, so if we put what a factor of 4 here, that is plus 4 atoms of what? Of 4 molecule of what? Of water. So I'm going to have 4 times 2 atoms of what? Of hydrogen. That will be what? 8. That will be 8. That will be balanced. Now let's just check for the oxygen. Okay, oxygen here is what? Is 4O, 4H2O. That means this 4 is affecting the hydrogen and the oxygen. Understand? Yeah. So we have 4 atoms of oxygen here. Yeah. How many atoms of oxygen do you have here? Okay. We have 6 atoms of what? Of oxygen here. Yes. Okay. So we have 4 here. Here we have what? 3 times 2. That is what? 6. Total is what? Is 10. Right. So now how many atoms of oxygen do you have on the what? On the reactant side? We have just 2. So what can we now do to make the number of atoms of oxygen here to be what? 10? Just like what? Like the product side. It's just by what? By adding 5. If we add 5 here plus 5, we're going to have what? 10 atoms of what? Of oxygen. That will make our reaction to be balanced. Are we clear? So that is that by that. So if you do not completely understand how we balance this, just take the video back again. You will understand. All right. So first of all, started with carbon. We balanced. We're going to hydrogen. We balance, and when we'll balance what the number of what? Oxygen atoms. Okay. So now we're told from the question that propane reacts with what? Oxygen gas to give us carbon dioxide and water. All right. So now they say if 2.8 moles of propane. If 2.8 moles of propane, so we're acting what? Comparing propane and what? React with excess oxygen gas. Okay, so how many grams of CO2 will form? Propane and CO2. That's what we are comparing. Okay, so propane, CO2, propane, CO2. Okay, we're giving the number of moles of what? Of propane, and we're looking for the number of what? The grams. We're looking for what? For the weight, okay, of what? Of CO2 that will form. Right, of the mass of what? CO2 that will form. Okay, so now this is a different question. That means this is from what? From mole to what? To gram question. All right, you get now. So we're converting from what? From mole to what? To gram. All right, now, so we are going to want to begin. What do we know, first of all? We are given the number of moles of propane, all right? And remember, we are going to work to grams, okay? We are given the number of moles of propane, all right? And we are not giving any other thing again in the question. So that means that what we have to first, we need to look for what? Look for the mass of what? Of propane that will react with what? With what? With CO2. Okay, that will react with what? With oxygen, right? That will give what? This CO2. Okay, since we know the number of moles, and we're looking for the mass of CO2 that will form, then we need to look for the mass of what? Of propane also. You get? Yeah? So now let's go on. So from the reaction, we have that what? 1 mole of C3H8 is what gave us what? How many moles of CO2? 3 moles of CO2. Okay? That one is clear from the equation. From the balanced chemical equation, that 1 mole of C3H8 gave us 3 moles of what? Of CO2. So what do we do now? We know the number of moles of propane, okay, that react to excess oxygen. We're looking for the mass of CO2. So we need to look for what? For the number, for the mass of propane that is actually reacting with oxygen. Okay, so now since you know that what? From your basic when we study what molar mass, relative molecular mass, and so on and so forth, we are talking about what? Number of moles, right? Number of moles is what? Is mass. The formula for looking for number of moles is mass of the substance over what? The molar mass of the substance. Okay? We're looking for what? For number of moles. Mass of substance over molar mass. That is the formula we use. Okay? So now, having known that also, it's also important that we can also look for number of moles. Is what? CV. That's what? Concentration times what? Times volume. Okay, so most of your question in JAMB, we are going to see what you giving the concentration of a substance, you giving the volume. You are told to look for the number of what? Of moles. Okay, so number of moles is what? Is CV. Okay, that's concentration times volume. It's another formula for finding number of moles. Okay, also you can also say that what? That number of moles is what? Is CV over 1000. So now the difference between these two is that what? In this case, we are given the volume. This volume is in what? Is in centimeter cube. Okay, if I give you the volume in centimeter cube, you divide by 1000. We're looking for the number of moles. We are given the volume, all right, in dm cube, in decimeter cube, that dm cube. We are going to just use number of moles equals to what? CV. Okay, so you use this when the volume is in dm cube, and use this when the volume is in cm cube. Okay, so please, I was just trying to bring that to your notice so that you completely understand what, completely understand it. All right, now let's go back to our question. Now, that means we need to look for the number, the molar mass of what? Of propane. Okay, so for us to be able to look for the what? For the mass. Okay, we need to look for the molar mass. So molar mass now, molar mass. You know how to calculate molar mass. You have what? Carbon is what? Carbon is 12. H is what? Is 1. Okay, so 3 times 12, that is 3 times what? 12. Then plus what? H8, that is what? 1 times what? 8. Okay, so if you do that, 3 times 12 is what? 36 plus 8, which will give us what? 44 gram per what? Mole. Okay, so that means the what? The molar mass of what? Of the molar mass of what? Of propane, C3H8 is what? Is 44 gram per mole. And since we know the molar mass, then of course we can now calculate what? The mass of propane, because we know the number of moles. So if number of moles now, number of moles is what? Of propane is what? 2.8 moles. Okay, and then molar mass is what? 44 gram per mole. Then we can look for what? We can look for what? Look for mass. From what? From the formula of what? Of number of moles. We said number of moles is what? Is mass of the substance over the molar mass of what? Of the substance. Okay, we know that, right? So I'm going to take that off because of space, please. So number of moles is mass over molar mass. That means that what? To look for what? For mass. To look for mass now, because to what now? Molar mass times what? Number of moles. Okay, so that will now be what? How to look for what? Our mass. Mass will be what? Look, let me show you clearly. Number of moles is mass over molar mass. Okay, if we're not looking for mass, what do we do? Cross multiply. It will be what? Molar, number of moles times molar mass. You get? That's how we got that formula. So mass is equal to molar mass times what? Number of moles. All right. So now that we have that, we can continue. Now, mass will now be equal to what? Now, what's the molar mass? 44 times what? 2.8. All right. That will give us what? So I need to press my calculator. Let me get my calculator. Okay. Getting my calculator. I'm using my phone here as my calculator, please. Do not be offended. So now I'm going to have 44 times 2.8. That will give us 123.2. Okay. So having 123.2 grams. Okay. So we know the mass of what? Of propane. Okay. So now can I bring our stoichiometry to play? Okay. Because we know that what? That 1 mole of what? C3H8 is what gave us 3 moles of what? Of CO2. Okay. Now, 123.2 gram. Okay. 123.2 gram, which compares to the what? To the mass, to the what? To the number of moles of propane. Okay. This mass compares to the number of moles of propane. So 123.2 gram. Okay. Of what now? Of propane will give us what now? Will give us X gram of what? X gram of CO2. So it's simple. It's as simple as ABC. So what you simply do is cross multiply. Okay. 1 times X is what? Is X. Then 3 times what? 3 times 123.2 gram. So that will give us what now? Use your calculator. Times what? Times 3. So our answer of what? 369.6 gram of what now? Of CO2. Okay, so our answer will be 369.6 gram of what? Of CO2. Because I'm explaining, that's why it looks like as if it's long, but it's very, very simple here. Yes, because we are told from the question to convert from what? From moles to gram. Okay, we'll use the information that we have. Okay, the information we have here is moles of propane, and since we know the moles of propane, we can now find the what? The mass of propane using number of moles equals to mass over molar mass. So once we know the mass, we can now draw out our stoichiometry. You can see we came back to our stoichiometric relationship. Okay, between what? Propane and CO2 in this reaction to be able to what? To get the what? To be able to get the mass of what? Of CO2. So it is very, very, very what? Important. Now, we have done this first part. Let's go to the second part. All right. So now, can't clean that reaction. The second part says that how many grams of oxygen? How many grams of oxygen? We're looking for grams now. Okay. How many grams of oxygen will completely react with 3.8 moles of C3H8? How many grams of oxygen will completely react with 3.8 moles of C3H8. Okay. Now, how many grams of oxygen react with what? Completely with what? 3.8 moles of C3H8. So from here, from our reaction here, okay, 1 mole of C3H8 is what gives us what? 5 moles of O2. For the second question now, 1 mole of C3H8 gives us 5 moles of what? Of oxygen. Okay. Now, 3.8 moles. What will 3.8 moles of C3H8 give us? Now, 3.8 moles of C3H8 will give us what? X to start with. So now, X times 1 is what? X. So I'm going to have S is equal to 3.8 times 5. If you do that, let's press our calculator again. 3.8 times 5 give us 3.8 times 5. It gives us what? 19. So how what? 19 what? Moles of what? Of X. Our X there is what? What's our X? O2. Yes, we are comparing what? Propane and what? And oxygen. So 3.8 moles of what? Propane will give us 19 moles of what? Of X. Okay, that means you will need what? 3. If you must use 3.8 moles here to react with what? With oxygen, it must be what? It will not be 5 moles again. It will be 19 moles. Okay, it will be 19 moles. Okay, that means this 5 moles of what? Oxygen will not be enough. Okay, it will not be limiting the reaction. Okay, but if we must use 3.8 moles here, you must use what? 19 moles of what? Of oxygen. Okay, so now, having known that, we're looking for the the grams, the mass of oxygen that will complete the react. Since we know the number of moles, okay, we know that what oxygen is diatomic. Okay, so the molar mass of oxygen will be what? O is 16. That is 16 times what? 2, which is equal to what? 32 grams per mole as the molar mass. Okay, because O is 2 here. O is 16. Okay, times 2 is what? 32 grams per mole. Okay, so now what do? We simply use our number of moles. It's called what? Mass over molar mass. Okay, that means our mass will be equal to what now? Number of moles times what now? Times molar mass. Okay, so which will give us what now? What number of moles there? It's 19 moles. That's 19 times what? Molar mass is what? It's 32. This will give what? That's 608 grams of what? Of O2. So you see that question is very, very easy. Okay, I'm converting from what? From gram to mole. All right, very, very simple. Okay, and we're on the reactant side. We know the stoichiometric relationship. All right, so it's just direct. So 1 mole of C3H8 give us 5 moles of O2. 3.8 moles of C3H8 will give us how many moles? 19 moles. So we know the number of moles of X now that we need of oxygen. Then what we need to do is to what? Look for what? For the molar mass. Once you know the molar mass, it's just to what? It's straight ahead. Straight ahead. So now let's go to the third question. So the third question, which says that if 25 grams of C3H8 reacts with excess oxygen, how many moles of water will form? So we are comparing what? This and this. Always get, first of all, understand what and what you are comparing. I'm giving C3H8 what and what? 4H2O. Okay, that's what we are comparing. Now, we're told that, all right, we are told that if 25 grams of C3H8, so we know the mass of what? C3H8, that's what that we are comparing with what? With the other, with the H2O. 25 grams, okay? So we need to first of all look for the number of moles. Okay, since we know the gram, we need to look for the number of what? Of moles of what? Of propane that will react with what? With oxygen to give us what? These 4 molecules of what? Of water. All right. So now let's go ahead. So we know mass to be what? 25 grams. Mass is what? 25 grams. All right. So molar mass of C3H8. Molar mass of C3H8 is what? What is molar mass of C3H8? We calculated it before to be what? 44 grams per mole. All right, if you remember. Yeah, so we're not going to go over that again. So now we can look for what? Number of moles of propane. Number of moles here of what now? That is mass over molar mass. Okay, 25 over 44 is what? So let's press our calculator. 25 divided by 44 will give us 0.557. Let us say 0.57 moles. Moles of what? Of propane. Okay, now, since we know the number of moles, then it's very easy. We can now use our stoichiometric relationship to what? To get the number of moles of water that will form. Now, let us go to our stoichiometric relationship. Remember, it's propane and water. Propane and H2O. Okay, so we have C3H8 here. So I'm going to have 1 mole of what? C3H8 gives us 4 moles of H2O. That's the first thing you need to get out. So now that we have gotten that out, what next do we know? We know that what? 25 grams corresponded to what? To 0.57 moles of what? Propane. So now 0.57 moles, okay, of what? C3H8 will give us what now? X moles of what? Of H2O. So what you simply do is what? Is to cross multiply. All right, 0.57 times 4 give us S. X times 1 is what? Is X. It's equal to 0.57 times what? 4. If you do that, press your calculator. I'm pressing my calculator. So you must press your 4 times what? 0.57. That will give us 2.28 moles. Okay, that's what? 2.28 moles of what? Of H2O. So you see, it's very, very simple. Okay, so converting from mole to gram or from gram to mole is a very, very simple conversion. Now, there's the last part of the question, which says that if 38 grams, you see, it is still this equation we are using here. This, what is it called? We're using this balance equation to solve all the questions. So you must first of all know how to balance your chemistry. If you don't know it, you are in wahala or in big Wahala, bro. If you do not know how to balance chemical equation, it's big problem for you, not for me. Okay, so let's get what the deep part out of the way. Please, it's pertinent. It's very important that you like this video. If you don't like this video, it is sheer wickedness. Right? Please, I've not even drank water. Look at my throat is dry. Just give it a like button. Just click on that like button right now. So you're watching that video now. Just click on that like button. Okay. And do not forget to subscribe. Subscription to this channel is free. FROEE. It send notification to your phone whenever we publish a new video. So it is for your help also. So please subscribe. All right, now let's do the D part. They say if that 8 grams of H2O are produced in the reaction, how many moles of CO2 were produced? That means H2O and what? H2O and CO2 is what we are comparing. Okay, they say if 38 grams of H2O are produced in the reaction, how many moles of CO2 were produced? So you see the same approach. So we know the mass of what? Of water. Mass is what? 38 grams. Okay, you need to look for what? For the molar mass of water. That is what? H2O. Okay, molar mass will be what? 2 times 1, then plus what? O is what? 16. All right, so I'm going to have what now? 2 plus 16, which equals what? 18 grams per what? Per mole. Okay, now since we know the molar mass, we can now look for what? For the number of moles of what? Of water. So number of moles will be equal to what now? Mass 38 grams over what? Molar mass 18 grams. Okay, so if we do that now, press a calculator, press it. It is meant to be pressed. So I'm going to have 38 divided by 18. Do not form that I to know. Press it to mass is 38 divided by what? Molar mass 18. 2.11. Okay, so having what? 2.11 moles. Okay, so know the number of moles of water that is what? That is formed. Okay, now that means we can now draw a comparison. From here is carbon dioxide and what? And water. So it is 3 moles of CO2 that give rise to what? Plus 4 moles of what? Of H2O. So I'm comparing 3 moles of CO2 and 4 moles of what? Of H2O. Okay, now so I'm going to have what here now? If 2.11 moles now of water, so is how many moles of CO2 is what we're looking for? So that means your S will be on what? On this CO2. We know that what? It is 2.11 moles of what? Of H2O. We have found the number of moles of H2O. So we're looking for the number of moles of CO2. What we do is cross multiply. 4 times what? X is equal to 3 times 2.11. Okay, so 4x is equal to what now? Press the calculator. Press and where? So let's press it. So I'm going to have 2.11 times 3. That gives us 6.33. 6.33. Okay, we're looking for x. Divide both sides by 4. So that what? X will be equal to what now? 6.33 divided by 4. That will give us 1.58 what? Moles of what now? Of CO2. So this is very, very simple. Okay, so we have now done a question that has to do with converting from what? From moles to gram and from gram to mole. So with this now, any question that comes under this section, okay, it will be very, very pretty easy for you to smash it and squeeze it with what? With your hand. Okay, now let's go to the last and final example before we end this class. All right, so I'm going to write the question on the board now very fast. Okay, so welcome back. So now here we have another question. Okay, now this borders on what? Converting from gram to what? To gram. All right, so it's still pretty easy. All right, so if I've been following from the first example, it is very easy. You have nothing to worry about. Okay, now let me check. Still. All right, so now let's go. Now we're giving what? This is our rule out for space. All right, so now we're giving what? Aluminium reacting with what? With chlorine. Okay, this is Al reacting with what? Cl. Chlorine is a diatomic what? Atom. Okay, or diatomic or element. So this will give us what now? AlCl3. Okay, so this will be what? The reaction. Aluminium reacting with chlorine to form aluminium chloride. This aluminium chloride, AlCl3. All right, you know why it's AlCl3 here? Aluminium has an oxidation state of 3. So they will exchange. If you have not watched all our previous episodes from the beginning, you see, everything you learn is important, okay? Everything you learn is important, okay? From episode 1, I started countering towards some topics, which is relevant here right now, all right? Okay, so please, if you like, play and don't watch. All right, now, please do not forget to like, do not forget to subscribe. Keep sharing these videos. Now, I'm giving AL plus what? CL2 to give us AlCl3. Is it balanced, first of all? No, it's not. So we have what? Aluminium, first of all. Aluminium, first of all, seems to be balanced here. Yes. So let's go to chlorine. Chlorine is 2 here. Yes, 3. Okay. So that means that if we put 2 here, all right, we got 2 aluminium, 2 times 3 chlorine. That is 6 what? Chlorine. Okay, 2. This is 2. All right. So now, if you put 3 here, this will be what now? 6 what? Chlorine. Okay, but aluminium will not be balanced, so you have to put 2 here to balance aluminium. So our balance equation there will be what now? 2AlCl3. All right. 2AlCl3. That will be our balance what? Chemical equation. Now we can now proceed with our what? With answering our question. Say if 35 grams of aluminium reacts with what? With excess chlorine. 35 grams of aluminium react with excess chlorine. How many grams of aluminium chloride will form? So it's still the same thing. You must use what you have to get what you want. So that means we can now what? Compare between what? Aluminium. Look at now. Compare between aluminium and what? And what? Aluminium chloride. Okay, that's what? 2Al and what? 2AlCl3. Okay, so from here it means that if you use what? 3Al, I'm going to have what? 3AlCl3 here. If you use 100Al, because of what? The ratio in which they are combining. Look at the ratio is what? 2:2. The simpler form is what? 1:1. All right. So if you use 1 billion aluminium here, I'm going to have 1 billion aluminium chloride here because of the ratio in which what? They are the mole ratio, right? In which they are reacting. Okay. So now let's get it clear. So now that means that what? 2 moles of what? Al will give us 2 moles of what? AlCl3. All right. Now given the mass, 35 grams. If 35 grams of aluminium react with excess chlorine, how many grams of aluminium chloride will form? So from the question we have what? The mass of what? Of aluminium. Okay, so we can look for the number of moles of what? Of aluminium. Okay, that will react there. Okay, so now let's go. So that we're going to have what now? We have mass is what? 35 what? Gram. Yeah. So we have what? Molar mass. Molar mass of aluminium is what? Is 27. Okay, it's 27 gram per mole. You must know that. Okay, you'll be given the question in case you do not even know it. You're supposed to be given the question, but if you do not know it, all those things that are common elements that you're supposed to know that molar what mass. Okay, so now molar mass is what? 27 gram per mole. So can I look for what? Number of moles. So number of moles is because of what now? Mass 35 over what? 27 molar mass. So if you press your calculator, let me press my calculator here. 35 divided by what? 27. They give you a 1.29. I'm going to have 1.296 gram. That is moles. I'm going to get to 1.296 moles. So now I will know the number of moles of what? Of aluminium. Yeah, we can now draw up our stoichiometric relationship, because here we know that what? That's 2 moles of aluminium. Okay, give us what? 2 moles of what? Of AlCl3. Now 35 over 27, that's 1.296 moles. 1.296 moles will give us what now? X. Okay, from what? From our stoichiometric relationship, it's already very obvious that what is 1 to 1. So our X also, because of what? 1.296 moles. So the number of moles of what? Of aluminum chloride that will form will also be 1.296 moles. But we are not concerned about the number of moles of aluminum that will form. Rather, we are concerned about what? The mass of aluminum chloride. Okay, we are not concerned about the number of moles of aluminum chloride. We are concerned about the mass of aluminum chloride. Since you know the number of moles, is to look for the molar mass of what? Aluminum chloride. Molar mass of aluminum chloride. What is the molar mass of aluminum chloride? Aluminum itself is what? Is 27. Is 27. We need to look for what? The molar mass of this. That is what? 27. Then plus what now? 35.5 into what? 3. All right? We get it. So now molar mass is what? 27 plus what is 35.5 times 3? So we do that. 35.5 times 3. 106. Point what? 0.5. All right. So now 106.5 plus 27 will give us 133.5 what gram per mole. Okay, so we're concerned about what the mass. So mass will be what now? Number of moles times what? Times what? Molar mass. So now what? Mass of AlCl3 because of what now? 1.296 times what? 133.5. All right. So if we do that now, times 1.296, that will give us what now? 173.01 gram. So it is pretty what very straightforward. So we use what you have to get what we want. We know the number of moles of aluminium. Sorry, we are given the number of what? We are given the mass of aluminium. So to look for the number of moles, okay, of what this aluminium, so that we can now use the word to find the number of moles of this aluminium chloride that will form. Since we now get the number of moles, we can then what? Just straightforward what? Calculate the molar mass and then what? Get our answer. Very easy. So now let's go to the second part of the question. That is what 2Al plus what 3Cl2. Then to give us what? Is that 2 or 3? 2AlCl or 3. 6. So it's balanced. Now let's go. How many grams of chlorine will react completely with what? 42.8 grams of aluminium. So here we are given the mass of aluminium. So mass of what? Of Al is what? 42.8 gram. Yes. So we need to look for the number of moles of what? Of aluminium that what actually what reacts. Okay, so now molar mass of aluminium. Well, molar mass of aluminium is 27. We know that already, yes. So mass, number of moles now will be what now? Mass 42.8 over what? 27 over molar mass. So if we do this calculation, we should have what? Let's check. 42.8 divided by 27 is what? 1.58. Okay? 1.58 or 59. Okay, this is 585. So let us say 1.59 what? Moles. Since we know the number of moles now, we can now draw up our stoichiometric what relationship between what? Chlorine and what? And aluminium. That is what? Chlorine and aluminium. So it is 2 moles to what? 3 moles from the reaction, from our balanced chemical what reaction. So now 1.59 moles now is of aluminium. So 1.59 moles will give us what now? X. So we cross multiply. 2x is equals to 3 times 1.59 times 3. I'm going to have 4.75. Okay, so x will be equals to what? Divide both sides by 2. Divided by 2. I'm going to have 2.37. Let me just say 38. Let me round it up to 38 what? Moles. All right, so that's what we are going to have. Okay, so we found the word number of moles. They are looking for number of moles of what? Of chlorine. All right, so now that will give us 2.38 moles. So now, of course, let us now look for what? The mass of what? Of chlorine. Okay, we know that what? That molar mass of chlorine. Molar mass is what? Will be equals to what now? No, chlorine here is what? Is diatomic. Okay. Is 35.5. Okay, I'm going to have what? 35.5 into what? 2. So if we do that, I'm going to have 35.5 times 2, 71. All right, so we know the molar mass. So I'm looking for mass. So of course, mass is what? Number of moles times what? Times molar mass. Okay, so if we do that, I'm going to have number of moles there is what? Is 2.38 times 71. That will give us what now? Times 2.38. You are 168.98 what? Gram. Very simple as ABC. So this is how what to solve questions on stoichiometry. Okay, so with this knowledge, there's no question that should come out on that stoichiometry that you should not be able to answer. Mole to mole, gram to mole, mole to gram, or gram to gram. It's the same what approach. Just follow this approach. You are going to get it very correctly. All right, this video has been too long, so thank you so much for staying put. All right, my name is Master T, your favorite chemistry teacher, and I'll see you in the next episode when we start talking about chemical energetics. Thank you for watching.